Welcome back. It's week 6 and I'm now in 1080p. This week I've gotten my bandsaw set up, which took longer than expected, and now it's raining so I can't use it. I also got new mill parts, this is the old one, installed, but I haven't tested them yet. Maybe that's something to do after making this video today. Didn't manage to make any new parts, but I did do a lot of modification on the 3D model to make sure that all the pieces would fit in the range that my bandsaw can handle. And now, since a lot of this project is about the history, I'm going to be talking about the precision manufacturing that had been started before Babbage, but was really getting going around his time, and how much of what we have today was not even imaginable back then. Today, for $20, you can get calipers, which measure down to 5/10,000ths of an inch, which is an order of magnitude less than a piece of paper. But before the 1800s, that wasn't possible with any equipment. Before that, in 1751, it all started with Jacques Vaucanson, who made the first all-metal lathe. Now, lathes had been around for a few thousand years, but they were wood, so you weren't getting very much precision out of them. And this lathe is the machine that makes all the machines. Since it was all metal, it was much more rigid, and you could get higher tolerances and make metal parts with it. So if you're making a precision machine, you need a precision machine to start with. Sort of like a 3D printer that 3D prints another 3D printer. In 1760, he made a rotary file, which is sort of the predecessor of a vertical mill, but it's more like a Dremel tool where it's grinding rather than cutting, and it was used for finishing gear teeth, which is a very common use for all these machine tools. Moving to 1800, Henry Maudslay makes the first screw lathe for making screws, which were previously hand-filed. So using this lathe, you can get the repeatability of the same size screw without hours and hours of handwork. He also makes the first micrometer that can accurately go down to 1/10,000th of an inch, and has a machine shop that will spawn many of the other people we're going to talk about here. Also in the early 1800s in the US, you get people starting to make milling machines, like Eli Whitney in 1818, and that's part of the interchangeable parts that you hear about in your elementary school history lessons. Not until the 1860s would something be recognizable as a modern milling machine with 3 axes that move independently, and the Bridgeport mill didn't come around until 1938, so that's 120 years later from the first usable milling machines to the type we actually use today. In 1823, as Babbage is working on his first difference engine, he hires a machine shop run by Joseph Clement, who is known for precision lathes. And Clement had previously worked at Maudslay's until 1817, and then he started his own shop. And they were working on Difference Engine 1, which had pieces built but was never finished. In the early 1830s, Babbage builds his own shop, but Clement refuses to move, and that is basically where Difference Engine 1 ends. During that fight, Clement has all the tools and all the drawings, and Babbage is left to himself, so that's when he starts working on the Analytical engine. Had they worked together, maybe the Analytical engine would have been delayed by decades or never even started. At his machine shop, Clement hired Whitworth, who had, again, previously worked with Maudslay, and Whitworth eventually becomes the foreman, and they're doing precision manufacturing. They have to make all their own tools, so they're inventing tools like planers and shapers, and they're figuring out how to manufacture things with precision more quickly and how to measure that precision better. In 1833, the same time that Clement and Babbage are fighting, Whitworth starts his own company, and he's making surface plates, which are very flat pieces, usually of granite, to measure the height of pieces and also the flatness of other parts. By 1841, Whitworth is working on standard screw threads. Now, other people had thought of standard screw threads, but Whitworth is the one who got the British railroads to use them, which meant the entire country used them and the entire British Empire used them. So those standards went worldwide and everybody started manufacturing to the same specifications. It was called the BSW thread, or British Standard Whitworth, and it's still used today as the BSP thread, British Standard Pipe. You can buy airbrush hoses on Amazon that have the same thread that he came up with 150 years ago. The BSW screws became less useful when steel came around. they weren't the correct shape for used in steel as opposed to iron. Whitworth also used his precision manufacturing to make accurate rifles, which made their way to the Confederacy in the Civil War. So there's a saying that Babbage made Clement, Clement made Whitworth, and Whitworth made British manufacturing. So like the computer history video, you can see that all these ideas come from multiple people working together over time, and it's never as simple as your history lessons will tell you. So now that I'm not waiting for any more tools, hopefully I'll start making more parts, but I seem to say that every week. Thanks for watching, and enjoy more of my bandsaw cutting through big blocks of aluminum.